Welcome to our series on Introductory Statistics. My name is Mark Ledbetter, and this is the video number 1. I'm going to introduce the study of statistics and then get started in Chapter 1, Part 1. In this video, we're going to introduce the study of statistics. I'm going to give you a brief outline of what we're going to cover this semester, and then we're going to dive into some basic vocabulary. So what is statistics? Well, I could give you the boring definition, which most books and the encyclopedias and dictionaries have. The science of collecting data, organizing data, summarizing, presenting, planning, performing experiments, analyzing data, interpreting results, drawing conclusions, and presenting data. Whew, I'm sleepy already. So what is statistics, though? The exciting version is it's being able to discover something about almost any population using a very small sample, at least relative to the whole population. And unlike physics, where you need to know the formula for gravity to talk about the gravity, or the formula E equals mc squared to talk about the transfer of mass to energy, or a formula for acceleration, velocity, etc. Then you use those formulas. But in statistics, we can study things that we have no clear idea of the underlying underlying equations or laws that govern that situation. So it's very powerful, and that is why I love statistics. Now, there are two areas in statistics that we sometimes divide the data in, or the study of statistics into, especially in an introductory course. And we talk about descriptive statistics, and that's the organizing of data, summarizing it, maybe using a picture. But it's necessary to do this, but this is not by itself statistics, at least the way I think about it. So it's important to do this, and we'll find out that it's very important in Chapter 4. If you don't do this, descriptive statistics, then you could make an error when you get to the inferential side of things. So every good statistical analysis needs to include descriptive statistics, but that's not usually where we stop. So where we like to go usually is inferential statistics, and that's drawing conclusions about the population from a small sample. Okay, so let's look at an example. Let's say that our population includes all the people in Virginia that contracted the COVID-19 virus, and we want to study this. We want to know something about this. So what we do is we draw a random sample, which is fairly small. So we start randomly selecting individuals from that population, and that becomes our sample, which is the oval on the right side. We analyze that sample, we perform calculations, we use statistical techniques, and then we can draw conclusions about the whole population. So the catch here is that with statistics, there is always some level of uncertainty. We can never be 100%. But we can control how much uncertainty we have. It's very reasonable in many situations for us to be 99.9% confident in our results. We can get that close, but we can never get to 100. Okay? We need to walk before we can run, and so statistics is a very broad term. And I've listed out several areas of expertise within statistics, sub areas that people specialize in. And probability is one of those. And as an area of expertise is very mathematically involved and complex, but it's also referred to as the foundation of statistics. And it is the more basic principles of probability are required throughout statistics. So we don't have statistics without probability. I've listed out sampling theory. So all of the ones listed pass sampling theory, and there are many more. require sampling theory in order to get or obtain good results. Okay? And then we look at estimation and inference. And those are extensions of decision theory and prediction and modeling. So all of these different areas of expertise exist, but there's no clear line to say when we leave one and go to the other. There's a lot of overlap here. Okay? So in order to do this semester, we need to start off with some vocabulary and some notation. You're going to have to learn a lot of new terms and definitions and just know how to use them. I'm not going to make you regurgitate definitions, but you need to understand what's being said. And there's a lot of new notation, symbols. So we use a lot of Greek letters and a lot of English letters, if you will. And once we know the vocabulary, then we can start learning how to calculate different quantities and looking up and calculating different probabilities. And so there's a lot of math involved. There's a lot of mechanics involved before we can ever even think about doing inferential statistics. So once we have learned how to do all these calculations, then somewhere near the end of the course, we'll be able to put it together and start doing inference. Okay? So we're using the book Understanding Basic Statistics by Brase and Brase, the 7th edition. And we're going to cover in this semester chapters 1 through 4, and then we're going to skip over to chapters 7 through 9, and we're going to complete them, and then we're going to cover as much of chapter 10 and 11 as possible. So that's our outline for this semester. So let's jump right into some basic concepts. The first of which is, what kind of studies do we do in statistics? Well, there's two basic types: observational studies and experimental designs. So in this course and in most courses, we deal with observational studies. This is where we analyze data that has been collected without the researcher or anyone influencing or interfering with the results. Experimental design is very different. It's a more advanced topic, and what we do there is we design an experiment using subject matter expertise and statistical expertise, and we control the conditions under which things are created or produced, and we control the environment, and then when we're done, the results can help us either prove or disprove cause and effect. All right. Experimental design is the only area in statistics where we can actually prove cause and effect. Now let's talk about data and some terms that go with data. An individual is a term for any member of our population that we're wanting to study, or the population of interest. A variable is something that varies in value, as its name implies, and it's something that we're going to measure or observe on the individuals. It could be height, length, distance, pressure, weight, something along those lines. Population data is a term that refers to measurements or observations from the entire population of interest, and we call this a census. And the U.S. does a census every 10 years, or attempts to. And then we have sample data, and again, it's data that's collected just from our sample, which is just a portion of the entire population. Now, there are many types of sample or sampling techniques, and the book in section 1.2 does discuss these, and they're interesting, but we're not going to deal with them in this course, so I'm not going to cover them. But the types of samples that we are going to cover in this course include a random sample and a simple random sample. And some people have trouble determining which is which. So a random sample means that any individual in the population has exactly the same chance or probability of being selected. A simple random sample now does not talk about an individual, it talks about a group of individuals. Let's say size n. So we could let size n be, say, 30. Then a simple random sample of size 30 means that it's a sample of 30 individuals, and the chance of us selecting that particular group of 30 individuals in the population is exactly the same as any other group of 30. And we are talking about all the possible groups of 30, so there's a lot of overlap here. Okay? And we will use this when we get to inference in this course. Now, when we want to measure something about a population and determine something, we may be interested in, say, the mean lengths of fireflies. And so a mean is the same as an average. And if I'm interested in this population and I want to know what the mean of some value of the population is, that's a parameter. It's a true value that I don't know. In most cases, I won't know what this value is. So the concept of parameter goes with a population. Notice that parameter starts with a P over here. And notice that population starts with a P. And then statistics is a statistic is a measure on a sample. So it's that same characteristic or aspect of a sample. So it could be the mean or standard deviation of a sample. So, and again, statistics starts with an S, sample starts with an S. All right. So let's put this together in a brief example. So we want to study the average lengths of fireflies in Lynchburg, Virginia. To do this, we're going to use a little sampling theory. We're going to divide the city up into several thousand square grids of equal size. What we're trying to do is make it small enough to where if we send one person to that grid, they can easily handle or measure the fireflies on that one grid. So, and then just as a random number that I chose, let's say we randomly select 20 of those grids, and we send a researcher to each of those grids at dusk, and for 10 minutes, they're going to capture as many fireflies as they can, and then measure their length, and then release them without hurting them, okay? So we don't want any cruelty to fireflies, all right. So what is the population and what's the sample here? Well, the population are all the fireflies in Lynchburg, and there's no way we could measure all of them, and we wouldn't want to either. And then a sample, in this case, are the fireflies that were captured and measured by the researchers and released. All right. So what's a parameter? Based on this study, we said we wanted the average length of fireflies. That's what we're studying. So for this study, the parameter would be the average length of all fireflies in Lynchburg, not in Virginia, not anywhere else. We've defined our population as all the fireflies in Lynchburg, so the parameter is the average length of that population. And the statistic would be the average length of the fireflies that were measured. All right, well, I hope this helps put those first few basic concepts together and makes it a little more understanding. Now, as I've mentioned in the starting here video for this course, I'm requiring that you take lecture notes on each of the videos. And these are your lecture notes, but I'm requiring that you do that and then scan them in to the Google Drive that I've shared with you. And this counts as part of your participation grade. And I believe it's 20%. So it's a very large portion of your grade. So please make sure that you do that. And I've said extra points for neatness, but really this is for you. These notes are for you to go back and study. They're to help you when you do homework, help you study for tests, help you when you do your projects. All right. Well, I hope you've enjoyed this, and I hope to see you next time. Until then, think statistics.